Hello everyone. Today we are just going to start the class with all concept of the first chapter, chemical reactions and equation. So from the very basic, today I am starting the video. Please be patient as the video will be long. So at first we have to understand what is a chemical reaction. Chemical reaction, we know it is a process by which we are able to obtain some new substances with some new properties. So how we are obtaining the new substance? But when one or two different reactants are there or different substances are there who are reacting with respect to each other. Now in a chemical reaction, two things you have to remember that there are the two sides of a reaction. One is the reactant side, another is the product side. What are the reactants? That means the chemical substances who are participating with each other in a chemical reaction, or there is a rearrangement of atoms is done in the reactant side. Thus we are able to obtain a new product. The new product is not coming from some other place. The new product we are able to obtain from the rearrangement in the reactant side only. Okay. So we can say that in a chemical reaction, the reactants are reacting with each other. So that's why we are able to obtain a product. Now remember this funny example at the beginning of this chapter I had just given to you. That means these two are the reaction. In the left hand side of this chemical reaction, these two are the reactants who are reacting with each other and we are able to obtain a new product. Now the first reaction, this type of chemical reaction, even this chemical reaction I have asked several times, but you people forgot that one. Please try to remember that whenever we are burning the magnesium ribbon, that means the magnesium is reacting with oxygen and we are able to get the magnesium oxide. It is a white powder. But before burning the magnesium ribbon with oxygen, we have to clean that magnesium ribbon, because already there are some magnesium oxide layer which is present on that magnesium ribbon. At first we have to clean that one, then we should go for the burning of that magnesium ribbon. After the burning process we are able to get that this is the magnesium oxide. So if we see another side of this chemical reaction, that we can say this is a oxidation process, or this is a combustion reaction, this is a combination reaction, right? Why I am telling this is an oxidation process? Because oxygen is added with magnesium and we are getting the magnesium oxide. Whenever oxygen is added with some substance, we are able to say this is the oxidation reaction. And sorry, magnesium is oxidized to magnesium oxide. The second part, that it is a combination reaction, because magnesium is combined with oxygen and we are able to get magnesium oxide, right? It is a combustion reaction because whenever you will burn this oxygen, obviously some heat energy you have to just supply, thus we are able to get this magnesium oxide. The last point that I want to include, that here magnesium and oxygen both are the reactants and magnesium oxide is the product. So how many parts we are able to analyze with respect to a single reaction? Whenever you will learn, whenever you will remember any reaction, you have to just see the other sides of this chemical reaction. In how many ways you can define that. Now in this case, there we have seen some of the chemical reactions that occurs in nature, right? That is the fermentation of grapes, the rusting of iron, even whenever the glucose is reacting with oxygen, even the formation of curd also. These all reactions that are actually occurring in nature, right? They don't need any particular laboratory. Now the combustion of fuels. Combustion means whenever any substance is reacting with oxygen. You can say every combustion reaction is an oxidation. Now here we have taken some examples, that coal, oil, natural gas. They are actually burnt, thus we are able to get the heat energy. So they are The Whenever we are burning them, that type of reaction is known as combustion reaction of that fuels. Now, whenever the candle is burned in presence of oxygen, now the temperature is being changed, right? So, by the changing of the temperature, we are able to say that there some chemical reaction is being happened. Now, whenever some fruit is getting ripe, so we can see that there is a change in color of a ripe mango instead of a raw one, right? So, there are some characteristics by which we can say that a chemical reaction is happened. So there are five characteristics by which we can say that a chemical reaction is happened. That is, the first one is evolution of a gas, second one is formation of a precipitate, third one is changing of color, fourth one is change in temperature, and the last one is change in state. We will analyze each and every characteristics of a chemical reaction. Now, the one of the most popular, one of the most trending equation we have, that the zinc granules are reacting with sulfuric acid, and we are able to get the zinc sulfate and a hydrogen gas. Whenever at the starting of this chapter, we are just discussing the same things, but I had not told you some of the things. Because if I tell you at that time, you will not able to understand. If I say that this is a single displacement reaction, then now you are able to understand, because now the chapter is finished, right? You know what is a displacement reaction. Now, why I am saying it is a displacement reaction, as you can see in the reactant side there was the sulfuric acid. That means the hydrogen is bonded with the sulfate, but whenever the reaction is happened, the hydrogen is being substituted, or the hydrogen is being displaced by the zinc. So that's why we are able to get the zinc sulfate here. So in this case, you can say this is a single displacement reaction, or simply you can say it is a displacement reaction. Whenever this reaction happens, there is an evolution of H2 gas. Now, the evolution of some gas you can show by an arrow in the upward direction, right? And here, remember one thing, the dilute sulfuric acid we are using, which are reacting with the zinc granules, and we are able to get zinc sulfate and hydrogen gas. So by the evolution of hydrogen gas, we are able to say that a chemical reaction is happened here. Now the next one. Oh, sorry, here the chemical reaction that I have not written. Let me write that one. Here the chemical reaction is between sodium carbonate and dilute hydrochloric acid. Sodium carbonate, that is of Na2CO3. It is reacting with dilute hydrochloric acid, that means dilute HCl, and we are able to get the carbon dioxide gas. But what is happening in this chemical reaction? Whenever the sodium carbonate is reacting with dilute sulfuric acid, we are able to get sodium chloride NaCl plus of carbon dioxide and some water molecule. Okay, so here we are able to get some evolution of carbon dioxide gas. So I will show an arrow in the upward direction. Okay, so in this chemical reaction, one thing you can do, you can indicate the state of each and every substances. As sodium carbonate is solid in nature, hydrochloric acid is the aqueous form, is in the aqueous form. Whenever you are using the dilute form, dilute hydrochloric acid or dilute sulfuric acid, it should be always in the aqueous form. Sodium carbonate, sodium chloride you are getting in the aqueous form. Carbon dioxide is a gas, water is in liquid form. So this is the chemical reaction for this condition. Now precipitate. What is a precipitate? Precipitate is a solid product which separates the solution during a chemical reaction. We know that. Now a precipitate is formed by different conditions actually. Here we have taken one example of the condition that whenever you will pass the carbon dioxide gas into lime water, you will get some precipitate. But which precipitate it is telling about? Lime water. What is lime water? Lime, that means the quick lime is having the formula of calcium. It is actually calcium oxide. Whenever it is reacting with water, we are able to get calcium hydroxide. Calcium hydroxide plus lot of heat energy. Now, If you pass carbon dioxide gas to lime water, lime water means I am just talking about this calcium hydroxide, slake lime. Calcium hydroxide is known as slake lime. So calcium hydroxide CaOH2 is reacting with carbon dioxide, and we are able to get a precipitate, that is of CaCO3. CaCO3 is actually a white color precipitate plus some water molecule we are also able to get. Now whenever you will be able to get a precipitate, you should give an arrow in the downward direction. So here the calcium hydroxide is reacting with carbon dioxide. When we are able to get the calcium carbonate, it's a white color precipitate plus some water molecule. So I hope you are able to understand that what is a precipitate and how we are able to get that. Now we have to write down the reactions for these two conditions as well. Now this chemical reaction is very important, everyone. The potassium iodide, that is of Ki, is reacting with lead nitrate. Lead nitrate PbNO3 2. Pb is the lead, NO3 2 is the nitrate. Whenever lead is reacting with nitrate, so we are having the formula PbNO3 2. Whenever potassium iodide is reacting with lead nitrate, we are able to get an yellow color precipitate of lead iodide. Lead iodide, that means of PbI2 plus of KNO3, potassium nitrate we are able to get. So in this chemical reaction, all of the reactions I am just writing down here, they are unbalanced. Whenever you will write down in your exam, you have to balance them by yourself. You just have to make the reactant side and the product side equal. Okay, it will take some time. I will just show you how to balance a chemical reaction also. So here potassium iodide is reacting with lead nitrate. We are able to get lead iodide and potassium nitrate. Here lead iodide is in white yellow color precipitate. Okay, lead iodide, as you can see here, it's a yellow color precipitate. So you should give an arrow in the downward direction. Now in this chemical reaction, whenever dilute sulfuric acid is reacting with barium chloride solution, we are able to get a white precipitate. Dilute sulfuric acid, that means of dilute H2SO4, whenever it is reacting with barium chloride, that means of BaCl2, it is A actually, okay. Whenever dilute sulfuric acid is reacting with barium chloride solution, then we are able to get the white precipitate, that means of BaSO4, barium sulfate, okay, and HCl. Now in this chemical reaction, we are able to get the white precipitate of barium sulfate, right? So I should give an arrow in the downward direction. Now whether you are able to say that what type of reaction it is. Now, if you can see the reactant side, there was sulfuric acid H2SO4. It is reacting with barium chloride. So, what is happened? Let me show you by some different technique. That is, BaSO4 is obtained like that. That means barium has founded the bond with the sulfate, and barium sulfate we are obtaining here. The hydrogen is forming the bonding with this chlorine. So here you can say that hydrogen is displaced by the barium and barium is displaced by the hydrogen, right? So it is a double displacement reaction. Let me tell you again, here sulfuric acid is reacting with barium chloride. Now if I just remove that circle, I hope it will be better to understand, right? Now here what happened, that a hydrogen is replaced by the barium and barium is replaced by the hydrogen. So it's a double displacement reaction. As you can see in the product side, we are able to get the barium sulfate, it's a white color precipitate, and some hydrochloric acid. Now changing color, whenever citric acid reacts with potassium permanganate solution, its purple color gets colorless. So how the chemical reaction we should write down? Remember the formula of citric acid, that is of C6H8O7. Whenever it is reacting with potassium permanganate, that is of K2, sorry, sorry, potassium permanganate, that is of KMnO4. Whenever they are just reacting with each other, we are able to get HMnO4 and here C6H5K3O7. Now in this chemical reaction, the hydrogen is replaced by the potassium and the potassium is also replaced by the hydrogen. So you can say it's a double displacement reaction, but instead of writing that one, you can write down the other double displacement examples that I have just given to you. It will be complex to explain for you. You just remember this chemical reaction for this condition only. That this is the citric acid. Okay, this is the citric acid and this is the potassium permanganate solution. Whenever they are just reacting, the potassium permanganate becomes colorless. Okay, you just remember this chemical reaction for this purpose. Don't use it for double displacement. Now sulfur dioxide gas is passed through an acidified potassium dichromate solution. Now acidified potassium dichromate solution, that means of H2SO4, this is the acid, potassium dichromate, that is of K2Cr2O7. Whenever we are passing the sulfur dioxide gas with that, we are able to get, that is of K2SO4 potassium sulfate and Cr2SO4 whole 3 and some water molecule, very small. But in this case, whenever the potassium dichromate solution is reacting with sulfur dioxide gas, the acidified potassium dichromate solution is reacting with sulfur dioxide gas, we are able to get the potassium sulfate K2SO4, chromium sulfate Cr2SO4O3 and some water molecule. So in this case we can say that there is a change in color because the potassium dichromate solution is actually orange in color. Whenever the reaction happens, it turns to green. As you can see in this diagram, the orange color potassium dichromate solution turns to green. So there is a change in color. So we are able to say that the chemical reaction is happened. The last one, that a quicklime reacts with water and it is forming the slick lime. That means of calcium oxide is reacting with water and we are able to get CaOH whole 2. That is the slick lime plus lot of heat energy. So we can say as the heat is getting evolved after the chemical reaction, so we can say that the reaction is endothermic in nature, and in this chemical reaction, by the evolution of the heat or by the raising of the temperature, we are able to say that a chemical reaction is being happened here. Now the last one, that is the change in state. So whenever the combustion reaction of candle wax is happened, that means the wax is solid in nature, but whenever you will apply some heat on the wax, that means some water is formed after the combustion of wax, which is liquid at the room temperature, and some carbon dioxide gas is also produced, right? So we can say that there is a change in state whenever we are applying some heat. So this is a combustion reaction of the candle wax where we are able to get that the some change in the state of the wax we are getting obtained. So by their change in state we can say that the chemical reaction is happened here.